In this video, I want to have a look at something called the trapezoidal rule. So in some situations, it might not be possible to calculate the area under a curve by evaluating an integral. So the trapezoidal rule is one method we can use to estimate that area. So let's have a look at how it works. So for example, if we had a function, f of x, and we wanted to find the area of this region here, so the area under the curve between the values of a and b. Now, if we can't evaluate the integral of that function, so we can't find the primitive function, one thing we can do is approximate this area using a straight line. So we're going to draw a straight line from here to here. So we'll join it together. And what we end up with is a trapezium. So now we can use the trapezium formula, and we're going to find the area of this whole region here. So it's not going to be exactly the area we wanted, but it is an approximation. All right, so the area of a trapezium is h over 2 outside of a plus b. Now h is the distance between our two parallel sides, the perpendicular distance. So that's the distance from a to b. So that h is going to be b minus a. So that distance along there. Now our a and b in this formula, which are different to these ones, makes it a little bit confusing, but these stand for the lengths of the parallel sides in our trapezium. So this point here, this side, is going to have a length equal to the function of a. So the function value of the function at that point. And this side here is going to have a length equal to the function value at that point there. So that's going to be f of a plus f of b. So writing that a little bit more formally, so the integral from a to b of f of x with respect to x is approximately equal to b minus a, so there are two x values, over 2, outside of f of a plus f of b. Now let's have a look at what that looks like with a few examples. Our first example asks us to use the trapezoidal rule to approximate the value of the integral from 1 to 5 of 1 on x dx. Now, before we use the trapezoidal rule, I just want to have a look at this. If we tried to integrate this, 1 on x is equal to x to the power of minus 1. If we tried to find the integral of that, our normal method doesn't work, because normally we'd be finding, increasing that power by 1, and then, so that would give us a power of 0, and then dividing by that new power, and this doesn't make any sense. So we can't use our normal method for solving this problem, which is why we're going to use the trapezoidal rule. So this is just a quick sketch of what our integral looks like. So say this is our x value of 1 here, and our x value of 5 up here, and we're finding this area in here. Alright, so to do this, we're going to write the integral from 1 to 5 of 1 over x dx is approximately equal to that 5 minus 1, so that's our b minus a, over 2, outside of, now we need our function value when x is equal to 5, and our function value when x is equal to 1. So just off to the side somewhere, say our function value when x is equal to 1, so we're going to substitute 1 into 1 on x, and we just get 1 over 1, which is 1. And our function value when x is equal to 5 would be 1 on 5. So there are our two values that we're going to put in our bracket. So we're going to have 1 plus 1/5. Now we can evaluate all of that, and we'll end up with 12 over 5, which is equal to 2.4. Now our second example is almost the same, except this time it's asked us to use two applications of the trapezoidal rule to approximate the value of that same integral. So what we did the first time, if we had our values of 1 and 5, was we drew a straight line between the two, and we found the area of that trapezium. What we're going to do this time is we're going to split that interval in half. So halfway between 1 and 5 is 3, and we're going to look at two smaller trapeziums instead. So what that means is it's going to be a lot more accurate. So the more rectangles you have, the more applications of the trapezoidal rule you do, the more accurate your answer is going to be. So let's have a look at what that's going to look like. So the integral from 1 to 5 of 1 on x dx, we're going to split that into two integrals. So 1 to 3 of 1 on x dx, plus from 3 to 5 of that same function. So now we can apply the trapezoidal rule to each of these integrals. So we already know that f of 1 is 1 and f of 5 is 1/5 from our last example. But we're also going to need f of 3, which would give us 1/3. So for this first one, we're going to have 3 minus 1 over 2, outside of f of 1 plus f of 3, so 1 plus 1/3. Plus, this one we're going to have 5 minus 3 over 2, outside of f of 3 plus f of 5, so 1/3 plus 1/5. And if we evaluate all of that, we'll end up with 28 over 15. Convert it to a decimal is approximately equal to 1.86, or it is equal to 1.86 recurring. So same integral that we're evaluating, but this answer is much more accurate than our 2.4 that we got in our first example, because we've done two applications of the trapezoidal rule instead. One thing it's important to understand about the trapezoidal rule is whether it's going to overestimate or underestimate our integral. So if our function is concave up, like the examples that we were just doing, so we had something like this, when we evaluated that integral with the trapezium, we ended up, instead of getting this area, we ended up getting this whole thing. So when it was concave up, it overestimated the integral. If our curve was concave down, and we wanted this area here, this whole thing here, when we draw a straight line in there, we're sort of chopping off this top little bit. So when it's concave down, we're going to underestimate the integral. If our function is linear, so it was actually just a straight line, then the trapezoidal rule would find the exact value of that integral. Right, so that's a quick look at the trapezoidal rule.